Thank you. Hello, everybody. Let's hope the presentation goes more smoothly than me opening the PDF. Probably it will. And I have a pointer. Yes, also works. Cool. I have the slides from my thesis presentation. The lecturer said to me, the supervisor, he said, well, the slides are good enough for the university course. So I thought, well, good enough for Pygrunn, of course. First, I was wondering who here has used neural networks for hobby projects at home. Can I have hands? Okay, so that's 40%, 30%, I think. People who used it in production. That's like 6, 8 people at most. Okay, so I will again, and I saw a presentation here before this, explain a bit about neural networks, and we'll keep it easy. The table of contents for today, introduction first, then I'm going to do some preliminaries. I'm going to talk about neural networks and some basic algorithms which are used for natural language processing. Next, my thesis was split in 2 parts, so we'll talk about the first part, which was about benchmarking, and it's about basically chatbots. So for chatbots, you want to classify what the user has said, what is his meaning of his sentence, and well, I made a benchmark to see which system is the best, basically, in classifying. And next, I have looked into improving accuracy. So what is the accuracy from, I have benchmarked the accuracy, and then my goal was to improve upon that. And I will conclude with the conclusions. At the top here in the slides, you can keep up where I am in my slides. So if you get bored and this is already colored, then you know, okay, we're almost done. So no worries. So first, the research questions. My graduation was at Spindle, by the way, and they wanted to automatically respond to customers using a few dozen pages of text. Basically, we had to update that because just reading text and not knowing anything about the text is too difficult at this moment. And we said, well, we're going to scope it a little bit smaller, because for just reading the text of which you know nothing, that is general artificial intelligence, and that's not really done yet. So we updated the scope to natural language understanding. That is, you get a sentence and you want to understand what is the meaning of the sentence. And you want to respond in real time because you're using a chatbot. That was the scope also. And you want to have a few training examples. I mean, neural networks usually have tens of thousands of examples. And well, I don't like doing that, and nobody does, I think. So we wanted maybe 100 or 200 training examples. So I looked into the existing benchmarks, and I found 4. There was one paper by Brown et al. From 2017. You had Snips. This is a company. They provide a chatbot for well, a speech assistant. You can put the device on your table, and you can talk to it, and you say, well, play me the newest song of that artist, for example. Burtsev, they provided Deep Pavlov. That is a Russian guys, researchers. They created a new framework for testing chatbots. They also created a benchmark, and you had BotFuel, another startup. Snips and BotFuel are both startups, and they all create a benchmark, and everybody concluded that they were the best. So there was some work that could be done there. And for example, Snips, they even provided in the blog post, they provided an example of some sentences, and well, they said, we want to do named entity recognition. So you have a word in that sentence, and you want to know what's the meaning of, what entity is it? So Sakaton is a city, and this gluten-free is about cuisine. And basically, Snips said in their example, oh, everybody was doing it wrong, and only we were correct. Yeah, okay, I doubt that. And their results were 80% for Snips, and the other all very poor. And basically, if you really dived into what they actually were doing, they were using a data set, a test set, which was very good fit for their algorithm they have developed. So it was not working in general. So I wanted to create an open source NLU benchmarking tool and develop it. And for the second, so I already introduced this, can the accuracy be increased and improve it? That was the goal. So first, the preliminaries about natural language processing and deep learning. So natural language processing is about, for text or speech, extract meaningful information and generate meaningful information. And for today, we will basically be focusing on extracting meaningful information. Where do you know this from? What have you used in practice? Probably you have used machine translation, where you extract the information from one sentence in let's say German, and then you generate it in English. And for speech recognition, maybe some of you use Siri or some Google Assistant. And named entity recognition, we'll explain it a bit. So what is London's location? And London is location, and weather is tomorrow is a date. That is one task, and also you have intent classification. So for this sentence, what is the intent of the sentence? This is important for chatbots, these two things, because when a user utters a sentence, you want to know what does the user want. So in this case, he wants to know the weather, but for what day does he want to know the weather? So in this case, it's tomorrow, so you need to extract that information from the sentence. And also, for what location does he want to know the weather? And this is London in this case. So the natural language processing started with statistical language models and to model the grammar of a language, because you need to know the grammar to understand a sentence. Without it, it's not useless. And they started with rule-based. I said statistical, but they started with rule-based. And what rule-based means is you try to define an entire language in rules. Well, you can imagine that is quite difficult. And while people have been doing that, you saw papers in the field from 1990, which were like 100 pages long, all kind of rules about language, and it was very difficult to create. And for companies to use it, you needed really experts in the field to create something meaningful, some meaningful system. So people switched to statistical language models. And how can you use such a statistical model? Well, the computer, because it's statistical, you can just read text and try to extract stuff from that automatically. Nobody needs to know anything basically about the language. And you can use it by, for example, spell correction. If you have my car broke, that's much more likely that sentence than the sentence my car broke. Then probably something is amiss, because you never, if you read, let's say, the entire Wikipedia, you will probably never see the sentence my car broke. So then you think, oh, something should be fixed here, so probably broke. For machine translation, if you are generating the sentence, let's say you read German and you're trying to generate English, do you have to order it in this way? Do you say the green house, or do you say the house green? Well, probably, again, the green house. And for speech recognition, you can apply the same thing by, instead of somebody saying she read R, the person probably means the red car. It sounds the same. Then language is a sequence of words. It's important what is the order of the words. So not tiger does that happy look. If you say that to your friend, he probably get mauled by a tiger, but maybe you can save his life by just saying that tiger does not look happy. And how they are using this sequence of words is they do account-based. So the probability for the car broke, for the sentence the car broke. Is everybody following, by the way? Who doesn't follow? Oh no, okay, great. I see a lot of nods. The car broke. You have the probability for this sentence is the probability of the word the, followed by the probability of the word car prepended with the, and probability for broke, where you have already seen the car. And people have implemented, you can implement that by just keeping all counts. So you have a lot of counts, and you just process an entire document, and you increment the counter for something you find. So let's say here you read the car, then you increase the counter for the car. And using this, you can determine all those probabilities. But in practice, this is not really useful, this stuff, because you need so many counters to have a meaningful representation of the grammar. Because, well, only 2 words, that's not enough, clearly. You also need the counters for 3 words, for 4 words, for 5 words. And then they used it in practice, and I think they were using 160 gigabytes of RAM for just keeping counters until 7 words. So that's basically if you try to do it yourself and you try to speak or read anything while forgetting everything further back than 7 words. That's not very useful. It's just not enough. They did make an approximation, and they said, well, you don't have to really calculate the entire sentence, but you can just take, let's say, the last 2 words, or last 3, or the last 4, and it's called n-grams. So, but you still have insufficient history, and, well, 160 gigabytes of RAM, that's not really mobile friendly. So they started to go to neural networks. And the basic model was the recurrent neural network. And these are really good in sequential data, so the thing we have. And let's say you have already processed my dog, and the next word is walks. Then they created a neural network which has the data flows from one step to the next. If I unfold this in time, that this is the clearer representation, but well, both this and this is the same. So you have your neural network processes then you go to the next step, then dogs comes in, and you go further. And here you want to predict walks, because if you have the sentence my dog, then it is likely that walks will be next, or some other word. This is just an example, of course. And how can you use that for translation? Well, just read the sentence in English in this instance, and you start spitting out the sentences in the other language. So here you read the, then you read red, then you read car, and then you're spitting out de, rode, and next would be auto. And what happens underneath is in that this line, so this is this part, the data gets passed through. This is a big matrix, and they call it a summary. And in the summary is everything what the neural network has read so far. So for each step, look at this point, in this summary, it will have contained the red car and the. So it knows that, well, you hope it knows that the next thing it should do is predict rode. But still they had insufficient history with recurrent neural nets, because, even for some sentence like this, you need definitely a few words. And in this case, we need a history of, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 words. And these, in practice, can only do 7. So if you want to translate a sentence like this, it's not going to work. So this is, by the way, also for Google Translate, the machinery they use. Yeah, well, they updated it now. Every year they've been updating. But they started off with this when Google Translate was starting. So they switched to gated recurrent neural networks. It was an extension on the recurrent neural networks, which improved the history it had. Basically, that's the only difference it has with the traditional architecture. And you have, well, the gated recurrent units and LSTMs, which are the long short-term memory. They are basically the same. They use the gates. And to give you an intuition about this, because basically the concept is very simple, what they do. They have that summary, which I just discussed, and they keep passing it through the states. But instead of, for every state, update the entire summary, they now start to update only a certain part of the matrix. And they only update a certain part, and they only read a certain part. And in practice, you saw that people have noticed that the readable subset, or that the algorithm learned to put, let's say, verbs on a certain part in the matrix, and to expect verbs at a certain part in the matrix. So that is quite cool. I'm now remembering, I have picked these slides, but I forgot, these do not include anything about neural networks, the basics, so apologies for that. But I can still show the concepts about the recurrent neural networks and stuff like that. I'm going to check the time, by the way. Okay. But yeah, the cool thing I think what is cool about this is that the concepts are really simple for neural networks. Because this was one of a very recent one. Oh, I didn't include the year, but from the top of my head, it was 2013 which they applied this, or 2015 maybe. So you would say that it's started to become really complicated in the last few years, but basically the concept they use are still quite simple. Then about my benchmarking, yeah, well, I had some data sets, I had some sentences, yeah, well, let's say web applications, how can I delete my Hunch account, or for the chatbot, when is the next train to Münsterfreiheit? For snips, I want to listen to Say It Again by Blackstrat Blues. So these are some examples. I had 4 data sets, and these are some examples from the data sets. And I've been looking at what products are available. So I already mentioned Deep Pavlov at the introduction, which is from some German researchers. It was open source, an open source chatbot. But you also have Rasa, it's also open source. And if you are going to experiment with chatbots, then use this one. This is a really cool product. And you can also go to Google Dialogflow, basically any big FAANG company, because Microsoft, Netflix, not Netflix, but Microsoft, Google, and Amazon, they all have their own chatbot, and basically they provide the same service. Maybe the accuracy of one system is a little bit better today for let's say Amazon, but tomorrow they might switch, and then Google is the best. So, and the interface is basically the same for all of them. For Rasa, they have, and this is also the same for other systems. You have a training data, and you give that to the system as a TXT file. Here you say, well, I have some sentences with the intent check balance. What is my balance? And in this case, this is a comment in this format. What is my balance? Then the intent is check balance. Or could I pay in yen? Then the intent is also check balance. And the named entities are also put inside this annotation. You have some intent greed and savings and stuff like, oh, sorry, this is synonyms. Also useful, then the neural network doesn't need to learn what are the synonyms. You can just specify them for certain domain-specific cases. That's useful. This is one of the systems I was talking about. So you had Google, you had Amazon, and Facebook even, and also IBM. And this is typically an interface you have. So you can just add intents. So you could use this, or you can use the graphical user interface. You could add intents, and then on the right side you can try it out. What happens is after you define some intents, it will train for like 10 seconds, and then you can try your chatbot out on the right side. This is for free, so if you have a weekend and no time in the weekend, you can try it out yourself. And what I find is that most of the time the accuracy is not yet enough for chatbots, but still they're working very hard on it. Every 2 months there is a new state-of-the-art algorithm. So yeah, maybe soon they will be good enough, and you will see chatbots all over the place. You never know, of course. Now in practice they are using it for KLM also, I think, and some other airliners worldwide, where you can just text to the company and you say, well, how late, what time is my flight leaving, and it will respond by the time your flight will leave. Stuff like that. So I created a benchmarking tool in Python, used Docker containers, was using the API calls from all the systems because, well, I want to create one benchmarking tool and I want to send all my data to all the different systems and then return from the, get back from them what their classification was. I then compare that with my what is the correct answer, and then I can determine the accuracy for each system. And one thing I have done is not object-oriented. I will not go into detail, but well, I think object-oriented sucks. By the way, anybody here who thinks object-oriented is okay, not so great? Does anybody agree on that? Ah, great! Already 6 people. Great. 5 more minutes, okay. So I did the measurements, And basically here you see that the accuracy for all the systems is very comparable. So if you're going to decide on what system you want to use, just pick the thing which is cheapest or most convenient you use, because for the accuracy it doesn't really matter. Also, if you change this, I've now tested this for these 3 data sets, but if for your company, for your problem, then you might need another data set, so then the accuracy could even be different for that thing. And well, some small things were interesting there. Then I've been working on improving accuracy, and that sounds really difficult, but basically it was quite easy because every 2 months there is a new algorithm. So that was what I had to do. I just picked the newest algorithm, implemented that, and I was done. So I picked BERT. Let's see. Well, I explained about recurrent neural networks and stuff like that. And BERT, this is using a transformer network introduced in 2017, and this BERT is introduced in 2018, both papers by Google. And at the time of, let's say, last year in November, they had the state of the art for 11 natural language processing tasks. So basically, any natural language problem, they were probably the best in that problem, in the task. It's a transformer model. It's a huge model, and where I was talking about recurrent neural networks, they try to keep the information from one step and just put it through the steps and try to remember it till the end. Well, the transformer basically, at any point in time, it can just look back at previous 124 tokens it has seen and just ask what's on that position or what is on that position. So that's a huge benefit. They use pre-training, and they sell with deep bidirectionality. I'm going to explain about that, and then I'm out of time. This is also a really cool concept, I think. Let's say you have this sentence and you want to predict what is the word in the middle. Does anybody want to make a prediction, because you're all neural networks? Sorry? Fool. The fool on the hill. Yeah, could be. Could be, yeah, definitely. So if here BERT, this is a picture from the paper from BERT, they compared their algorithm with other algorithms, and they say, well, notice that this one is called Elmo and this is called BERT. I didn't make it up. And they use a long short-term memory network, and they were walking from both sides to predict these words. So what's happening here is one of the long short-term memory is walking from one direction to that empty word there, and the other is walking from the other direction. And then to make the prediction for this word, they will both say, well, I think it's this, and the other one thinks also makes prediction for the word, and then they try to get a consensus on that, and then they're done. But BERT, the authors of BERT said, well, that's not good enough. You should use the context in every layer of the neural network, because that's much more useful. And the idea behind that is that while the network is trying to make sense of the sentence, it will. Do we have still have time? Okay, 1 minute, great. While the algorithm is trying to make sense of the sentence, it will. 1 second, I lost it. I had it in my mind yesterday. It's quite easy. Oh yeah, you have the words on both sides, and it could be some word which is important to determine this. So let's say hill is important to determine that word, and on the other side, let's say you have more words, and also here some word which is important to decide it. What is happening here in the long short-term memory is that they both read this, but that word, they basically forget it. They read the word, try to predict the word which should be on the gap, and from the other side they read the word and try to predict the word on the gap. But it might be that a certain combination of words on both sides of the sentences is very important to determine that word in the middle. And this doesn't use that, and this one, by the way, it only works from one way. And BERT, they use context from both sides. So in that way they have improved significantly, I think, over the other systems. So, and that was it.
I still wonder what's on the hill. King of the hill, or house on the hill?
I thought of a house.
Yeah, okay.
But well, it can be anything, of course.
Yes. So thanks, Rik. Any other questions? from the audience.
Yes?
Hello.
Hello.
I wondered about so you benchmarked on the accuracy,
Mm.
but did you also take into account the time it takes for the algorithms to perform, or were they all?
Yeah, very similar.
Okay.
I did take it into account, but very similar. And of course, the online solutions, I couldn't really benchmark the time because the latency is also involved, but it's all real time.
Okay, cool. Thank you.
Yeah, thank you for your question.
Thanks. I was wondering how long it takes to train a certain neural network, like BERT, or do you retrain it, or do you just?
BERT is already trained, indeed. So the authors have pre-trained the neural network, and they used tensor processing units for that. Basically, for the medium model, they used 4 tensor processing units. So that's basically a GPU with 16 gigabytes of RAM, and they ran it for 4 days, 4 of those. So that's huge. And the fine-tuning, so what you actually are using in production, that takes 1.5 days on a normal CPU, and on a high-end GPU, so 1,000 euros, it will take a few minutes. So quite long.
Yeah, okay, thank you.
More questions?
Yeah, one there. What is C?
I'll repeat the question. If I get it right,
okay.
the question is, are those models set in stone or like finished at some point, or do they evolve and can they train themselves?
What they use in production generally is not training again, because, and I think the reason for that is that if you have incorrect data, that you will add it to the training and your accuracy goes down significantly. But what you can do is just try to see what is happening in practice and add those sentences to your training examples. But yeah, definitely you could overnight, let's say, if the chatbot is not used, you could just train from scratch using all the kind of new sentences you have learned. But well, it's not so easy to get it right, I think.
Okay. Last question.
So thanks for the gentle introduction to natural language processing.
Yeah.
But since we're talking about language, how specific are these models and the trained networks themselves to the language they're trained on? Could I use the shape, the layout of the BERT network to also work for, I don't know, French or Russian? And do I just need to retrain it, or can I even just take the whole trained network and run it on a different language?
Very good question. That differs per algorithm they have used. Some are trained and can only be used for example, say English. They've learned the grammar for English and can only be used in English. But other models like BERT, they have a multilingual model, and they should be able to do 110 of the most used Wikipedia languages. That's how it's sold. But I do not know whether the accuracy also drops if you use the English model versus the multilingual model.
Okay, thanks Rik for all the awesome answers.
Yeah, thank you.